Hi everyone, I'm back. So now we are thrilled to introduce you our next esteemed speaker, Tatsuhiko Tsujino. Apologies if I'm not able to pronounce it correctly. As an assistant manager in the actuarial department at Nippon Life Insurance, Tatsuhiko brings a wealth of expertise and experience to our discussion today, with a focus on the topic extending the shifting logistic model with flexibility in mortality curves. Tatsuhiko will guide us through the intricacies of this fascinating subject. Without further ado, please give him a warm, please let's give him a warm welcome, and we eagerly anticipate your enlightening presentation. Thank you.
Thank you for a nice introduction. And hello, everyone. Thank you for listening to my presentation. My name is Tatsuhiko Tsujino. My name is a little difficult to pronounce, I think. Yeah. Today, I want to propose a mathematical model of human adult mortality, focusing on the recent trend of adult mortality curve and inspired by the existing method called the shifting logistic model. Okay, let me show you the outline of the presentation. First, I will introduce the background of this research. And secondly, I will propose a new method to model adult mortality, followed by the results of estimation and projection using the proposed model and some existing models. Then I will show you some issues about the proposed models. And lastly, I will conclude with a brief summary. Now let's get started with section 1. Okay, historically, human mortality has improved significantly. The graph shows trends of life expectancy at birth of some countries. We can observe a continuing increase of life expectancy and that the improvement accelerated since about the latter of the 19th century. In response to the improvement of human mortality, various mathematical models have been developed, such as Bongaarts maker, logistic, and Likert model. Their expressions are shown in the bottom right. Okay. Okay, let's look at the trend of mortality improvement more deeply. We can see two kinds of trend from these two charts representing mortality rates and survival rates. One is called rectangularization of survival curve, which means that the survival rate goes to the top right because of decrease in death of young people. And the other is shift of mortality to higher ages. I mean that mortality rate and survival rate keep their shape and get shifted to the right in each graph. This can be interpreted that deaths of old age people are delayed in recent years. Okay, next, I will introduce previous research which proposed a mathematical model focusing on the shift of mortality as seen now. Bongaarts found out that the slope parameter of the logistic model for adult mortality, denoted as beta, was nearly constant during the 20th century. Then he proposed the logistic model with fixed beta. In the shifting logistic model, the improvement of adult mortality from a specific year is expressed solely by the shift of curve to higher ages. In other words, the increase in alpha t or ST in the formula. Okay. And now here I show the shape of adult mortality has been changing recently in 2 points. And first, values of beta are increasing in these decades. Back to the last slide, and we can see that the values of beta seem to slightly go up in recent years. And second, the most recent adult mortality rises sharply at middle age and old ages. We can observe this two-step increase in the mortality in 2019 in the chart. These trends can't be captured by the shifting logistic model. So I will propose a new model which incorporates them in the next section. Okay, so let me introduce the new method. I formulated the new model simply by dividing the logistic model into two segments, middle ages and old ages. Here, the capital A is the term in order for this model to be continuous at K, or the connection point of the segments. Although it is not obvious where the connection point is, I assume K is equal to 65 in this study, based on the mortality curve seen in the last section. Actually, I tried other choices of K, but the estimation process is relatively stable and robust to data when K was 65. Okay, to estimate parameters of the model, I use the maximum likelihood method under the Poisson assumption. I mean that the number of deaths follows the Poisson distribution, of which average is expressed as the exposure of death times mortality. The function to be maximized is as shown in the bottom. Note that we can solve this maximization problem for each year t separately, because we assume that 5 parameters can vary for each year. Okay, next, as for data, I use human mortality data about death and birth, mainly in developed countries. And in this research, I use female data and aged from 25 to 100 for 15 countries, as shown in the table. Okay, and next, I will show you the results of estimation. At first, let's look over the estimated values of each parameter. These graphs represent the estimated values of alpha 1 and beta 1 for all 15 countries. The both parameters are relatively stable, which implies that the middle age mortality keeps its shape during this period. On the other hand, alpha 2 and beta 2 have downward and upward trend, respectively, which means that the shape of old age mortality has been changing constantly. Okay, and about alpha 3, which represents background mortality, it declined in the latter of the 20th century and then levels off. So the improvement of the background mortality is limited in recent years. Okay, as seen earlier, values of beta 1 are nearly constant in the period. Then, inspired by Bongaarts, I will propose another version of the new model where beta 1 is fixed over time. In practice, we first estimate the 5 parameters of the original model and obtain the fixed value of beta 1 as the average of beta 1 t's. Then we estimate the remaining 4 parameters again. The behaviors of the estimated parameters are similar to those of the original model. So here I omit the data. Okay, now I'll compare the fitting performance of the several mathematical models. 2 graphs represent the estimated and actual mortality curve in 1950 and 2019. In 1950, all models except for Lee Carter show pretty good performance. On the other hand, in 2019, only both versions of the proposed model seem to keep high-level performance. However, this result is obvious because the proposed models have more parameters than the other existing models. So I will evaluate these models numerically, taking into consideration the penalty on increase in the number of parameters. Okay, and here is the numerical result. Oh, sorry. Here's the numerical result. Okay, and the left half of the table shows the number of parameters for each model, and the right half shows the value of AIC. Each column corresponds to a result of a model, and LC is Lilicator, and LM is logistic model, and PM is the proposed model. And the proposed model have two versions, original and beta 1 fixed. Okay. Although the proposed models have more parameters than the other two, they obtain the first and second smallest AIC in almost all of 15 countries. Okay, and note that the original version of the proposed model is smaller AIC than the beta 1 fixed version for all countries. But the divergence between them is quite small in many countries. Okay, and additionally, I'll focus on the comparison of the proposed model and the logistic model because we can estimate parameters for each year independently only with these two models. The graph represents the difference of AIC for the proposed model and the logistic model for each year. We can see that the proposed model obtains rather smaller AICs than the logistic model, especially in these decades. This implies that the proposed model can effectively incorporate the new trend of the mortality curve, which cannot be captured by the logistic model. Okay, let's move on to projection of future mortality. In this study, using the data of period from 1950 to 2000, I forecast future mortalities up to 2100 for female in Japan. I'll compare three models, the proposed with beta 1 fixed, and the shifting logistic, and Lilicator. And I'll examine their projection results from the two viewpoints. The first is short-term projection, or to predict the mortality of 2010 and 2019, and compare how well the predicted mortality fits to the actual one. The second is long-term projection, or simply to compare the projected mortality curves for 2100. And to forecast future mortality, we need to extrapolate future values of parameters. I decided the way of extrapolation for each parameter according to the estimated values seen in the previous section. Here, I'll omit the detail of these methods. Instead, I'll show the paths of parameters as charts. Here is the chart. Yeah. As you can see, each parameter is extended linearly or flatly, depending on the trend seen in the data period. Data period is shown the left side of the vertical dashed line. Okay, so let's look at the results. Okay, at first, for short-term projection, the proposed model makes the best performance in terms of sum of squared errors, both in 2010 and 2019. We can also observe the fitness of the proposed model to the actual curve in the charts visually. Okay. And next, as for long-term projection, three curves diverge largely in 2100. Lilicator projection stands out in its extreme improvement of middle-age mortality. On the other hand, in the shifting logistic model, the old age mortality decreases largely because it forecasts future mortality simply by shifting a curve to the right uniformly. Note that in the proposed method, the mortality curve is not smooth at the connection point. The future mortality may have impractical shape, and we will need to apply some smoothing methods. Okay, based on the content so far, I'll introduce some points to be studied further. First is about choice of K. Although I assumed a fixed K in this research, we can consider a model where a value of K is also unknown. However, we should take care of robustness of estimation for such a case. Next, the idea of a mixed logistic model is also introduced in the related research, where adult mortality is divided into 3 parts. In this research, 2 segments model can describe the recent mortality curve well enough, but other choices can be considered and included in comparison. And next, related to the point mentioned now, we can think about a generalized model without any assumption on the number of segments. Such a model will have more flexibility in its shape, but it will be difficult to keep stability of the estimation process. And lastly, of course, the trend of mortality improvement will change over time. So we have to explore a better expression continually. And also, I only focused on the quantitative aspect of mortality improvement in this research, but it is necessary to understand that the background of the improvement from qualitative viewpoints. Okay, here is the summary of the presentation. I started with a brief introduction of the trend of adult mortality improvement, and I showed that there was a new trend. In other words, recent mortality curve had a shape of 2-step increase at middle ages and old ages. Then I proposed the new model by dividing the logistic model into 2 sections. Also, I tried another version where the slope parameter of middle age mortality, or beta 1, is fixed. The beta performance of the proposed model could be seen visually and numerically in estimating the past mortality curves and conducting short-term projections. Okay, this is all for my presentation. Thank you for listening.
Let's give a round of virtual applause to Tatsuhiko for his insightful presentation on the extension of the shifting logistic model with flexibility in mortality curves. We sincerely appreciate the depth of knowledge and expertise he shared with us today. Now it's time to transition to the interactive part of our session. I encourage you to take this opportunity to ask questions and seek further clarification on the topic. Tatsuhiko's expertise and experience make him the ideal resource to provide valuable insight and address any inquiries you may have. In fact, I have got 2 questions, so let's quickly start with that. What do you think? What are the applications of your research? If you could shed some light on this.
Okay, thank you for your question. I think the key point of this research is to estimate and predict the middle age and the old age mortality more accurately. So we can use this model for pricing the whole life annuity or planning the social security pension or a prediction of future demographics, I think.
Sounds good. If you could go back to the estimation slide where you had alpha 2 and beta 2, I noticed that it has got negative correlation. Could you help us explain that as well?
Thank you. Exactly. These parameters have negative correlation, and this means that the slope of the old age mortality gets steep, and the intercept goes down, and eventually the ultimate age hardly moves to the right. So if we apply this model for prediction of future mortality, we implicitly assume that the ultimate age doesn't move so far. So if this assumption is violated, we have to consider another parameterization or another formulation. Yeah.
Thank you, Tatsuhiko. So I have got a few questions from Evan and William as well. So let's quickly get them through as well. So what is the proportion of the people who opt for a value annuity versus lump sum or a fixed annuity?
Well, so this is a kind of theoretical project. So it's not based on an actual system which is operating at the moment, though you have variants of it in Sweden, in their what you'd call their second pillar, and in Singapore, where, and in the Swedish case, I'd have to double check the figures, but in the Swedish case, most people go for the value approach, as in the one which will pool mortality and grow over time, as opposed to the fixed insurance, which has a lower, which has a guaranteed payout, but doesn't offer the upside.
Yeah, I think that's always a challenge, that the lump sum, the big amount that people get with the lump sum and ability to spend it right away and so on is temptation. So you do need to be thoughtful about how to frame the choice, if there is a choice. But as we talked about, it's also important to consider setting up the lifelong income as a default, or even making it mandatory in order to get the desired participation in those solutions.
And it may be worth actually sort of mentioning a little bit about the Singaporean system here. So they have now a kind of effectively a required annuity, but because bequests are a very strong feature of the kind of culturally or the expressed desire of individuals, what they offer is 3 variants, where all of them effectively are kind of a variable annuity, though with some differences. But you can choose to have a lower one, a lower initial payout, which gives you a higher chance of a bequest, or correspondingly a higher payout initially that gives you a lower chance, or one which increases over time. And so if you're operating in the context of making sure that people are putting the money into a lifelong payout, then you could have some variants that fit the kind of the desires of a particular country, so you can tailor this to the country context.